All right, so this session, I wanted to just talk about measuring drop frames and animation smoothness, which is a project that the graphics metrics and Chrome Speed Metrics teams have been working on. And so I wanted today to cover sort of an introduction to introduce you to this idea of overall animation smoothness, the project that we're working on. I wanted to discuss sort of the differences between visual completeness and smoothness and latency and how we trade those off and what those implied for developers, where we are, where we're going, and how you might be able to play with it. All right, might as well get started with what is overall animation smoothness. So of course, we have a goal to label visual completeness of animation frames during animations. We'd like to make sure we identify those frames which matter the most to users. And we want to produce a metric like a Web Vital that measures the full page lifecycle of a page experience. Okay, so that's the goal behind the project. There's a web.dev/smoothness sort of blog post that is a long form text thing. And it's kind of the first of hopefully many that goes into the background and some of the details that goes in today and some of the nuances and things. It's not the end of the story by far, and hopefully we can continue to evolve. So, how is this project different than some of the existing metrics that we have already in Chrome or in Blink? So we want a metric that captures visual smoothness during active animations. There's a lot of metrics that capture sort of frame presentation times as a perspective of event latency or frame rendering opportunities and that sort of thing. But in this case, we want to focus specifically on active animations and overall smoothness. We also want a single metric that accounts for all animations. We have a bunch of metrics that account for very specific animations, but this needs to sort of be a unified metric. And we do want to measure like renderer performance, web page performance, which includes jank caused by developers. Some of the existing metrics want to isolate jank caused by developers so that it could be sort of things that Blink can improve on or that the browser can improve on. In this case, we want to focus on the end user perception, right? Was a given page experience actually painful to the user? And that last point, I think, is the most important part of this project as it differs from some of the other ones. So we want to measure not just sort of browser internals and the rendering pipeline itself, but what actually matters to users. It's not enough to have measured rendering deficiencies. There are plenty of rendering deficiencies all the time. We want to know what was observable and annoying to the user. It might be the case that some animations are inherently less important for users, or that users are more sensitive to a certain pattern of jank, and we as engineers might not be differentiating those cases just yet. And another point is in the precision versus recall debate. These are both very important, both precision and recall. And a lot of the metrics, I think, focus on recall, finding every particular issue, capturing any possible problem, and then driving those down. And certainly when you have plenty of sort of rendering issues, that is probably going to be a downside for users. But in this metric, I think we want to focus on precision. So if a site is scoring very poorly, it must be observably painful for users to use, even if things slip through the cracks sometimes. If that makes sense. All right, not to bury the lead, you can find existing UKM in Chromium under graphics smoothness normalized % drop frames. These are the sort of latest experimental metrics. There's a bunch of variants of different ways to define. They are proving useful, but they have known deficiencies. And so we plan to update this set before the end of the year, and we'll continue to iterate in 2022. But this is a place where you can already go find them for existing pages. Why do we want to work on this? So we want a better guardrail metric that does a better job capturing the real effect on user experience, first and foremost. Second, we want to complement existing web vitals. We already measured loading and responsiveness and visual stability, and we'd like animation smoothness to be included. But ultimately, we want to help developers help themselves. There's only so much optimization we can make in the browser and in the renderer. At some point, developers need to know how they can help improve. And that's kind of the critical bit. So hopefully today we can discuss some lab tooling or some of the other strategies that developers are already using in the wild. All right, so now let's discuss sort of visual completeness versus smoothness versus latency. All of these are important, but we're picking a particular battle here. So when it comes to visual completeness, for each frame rendering opportunity, it really comes down to how much work was included and presented. There really are just 4 states of a specific animation frame. It could either have no update desired, like there's just no damage, or sort of we discarded a bunch of work, or it was fully presented, or we only have a partially presented frame where we have like a compositor update without a main thread update, or we completely dropped an opportunity to present a frame. So these names, these labels, they come from Compositor Frame Reporter and Pipeline Reporter Trace Events, and you can learn more in Life of a Frame, as well as Badad's talk tomorrow called Tracing Frames 101. I didn't really want to dive into that today just because we have, I think it would take half an hour just to go into tracing. So come to that talk if you want to go into details. And then as a quick aside, I'll say that these states commonly refer to the ultimate state of the frame pixel buffer. So did we ultimately decide that we didn't need it? Did we present it? Did we drop it? But for this talk, I'm really less interested in the status of a frame buffer and more about the state of the presentation, what the user saw. All right. So with every frame presentation opportunity, so like vsync aligned, did we or didn't present everything the user would have expected that frame? Did we partially present? Did we drop the ball? That sort of thing. So there could be a difference when you dive into the data versus the terms that I'm using. Ultimately, this is meant to be user-centric. All right, so visual completeness is one thing, but there are other factors beyond just frames and whether they're updated or presented. So we can have a frame that does get presented, but that it has missing content or paint updates like checkerboarding. We can also have video frames presented at a perfectly smooth, like 60 frames a second, but the actual video bit rate could be very low. So the quality of the video stream could be very low. Similar for like Canvas, you can have a Canvas game that's running at a high refresh rate, but the content of the game, all the resource might not be loaded, or all of the sprites might not be doing what they're supposed to. So we want to be able to detect animations and somehow capture the importance and sort of the quality of the actual animations alongside just visual completeness. And so we begin to sort of define smoothness this way. So frame sequences become really important during active animations. Individual drop frames are bad for a whole slew of reasons beyond just animations. But we already have like loading paint metrics and responsiveness metrics and event loop long task metrics. So we have good coverage there for like what is the value of individual frames. So now we want to capture like what is it about sequences of frames? When does that become important? And of course, during animations is critical there, but there's also complicated relationship between animations and animation frames. So some animations only require partial frame updates, for example, and it's perfectly smooth if you just have partial frame updates for a particular type of animation. Other animations can sort of mask others. Like if you're actively swiping and scrolling, you might not even notice some main thread running animations. So for every frame opportunity, we need to classify which parts of the rendering pipeline updates actually affect smoothness. All right, this is probably a good moment to pause and ask if there are any questions so far. All right, you folks are quick. All right, so I don't know that I need to dwell on examples of animation updates. Here you go. And I've mentioned a few examples of non-animating updates like loading and responsiveness. These are the kinds of animations that we consider require compositor thread updates. And these are the kind of updates that happen on main thread that we consider animations. I guess I won't dwell here. I shared the bug. I shared this presentation so you can read more thoroughly. Also in the slide notes, there's links to other documents. I'll run ahead. So another interesting detail is when do we actually know if a main thread update in particular actually affects smoothness? We don't actually know until, like if there's a long task and the main thread update is falling behind and it doesn't meet its presentation deadline, we don't actually know if it will have a visual update. We don't know if that visual update will include an animation until that frame is complete. So we have to wait for the future in order to go back to the past and label frames, if that makes sense. So I think there's a limited amount of time that we'll wait before we just make a decision. I don't know if anyone on the call remembers. I think we wait up to 5 seconds. I don't think it's infinite. But Dad or John, do you happen to remember? No. All right. And so sometimes we wait for long tests to complete and sort of rewrite history. And so this might come up later when we look at some tooling differences about how different tools label existing smoothness issues. I don't know how well this slide comes across. I just recorded it this morning. And this is a way to visualize, I think for me, the difference between visual completeness and smoothness. So this is just me loading Wikipedia this morning. This is a random article that I clicked on. And you could see the main thread, event loop on the bottom. And you see there are a few long tasks on the second half of this timeline that I screenshotted. All right. And that means that the main thread was blocked. There was no ability to produce new paint updates. But if you look at the frames at the top, there are a bunch of screenshots, which means there were new visual updates. And the frames are labeled as green, which means they were fully presented from the perspective of smoothness. So even though main thread was blocked, and even though there was no new visual update with the content that was there, it wasn't affecting smoothness. All right, so the frames weren't visually complete, but there were no animations running. And so that's why you might get a mismatch between, did the frame have a particular update, or was it affecting smoothness? All right. And similarly, I think this screenshot showcases a difference between latency and smoothness. So here on the bottom left of the main, the event loop, as you would see in DevTools if you did a performance recording, you see there were a few new paint operations, a few new request animation frames, a few new frames generated. But they don't actually get displayed until sometime later. There's a bit of latency between when the frame is produced to when it's shown on screen. And so you see some frame updates at the top that are perfectly green because there's a fully formed frame update. But in DevTools on the bottom, you see there's this huge long task. So this first frame, I mean, it kind of makes sense. There's a little bit of an alignment there within the vsync boundary, but the second frame is perfectly green, even though we have a long task blocking main. And that is producing a visual update. So in this case, it's just because there's latency. There's latency from when the frame is produced to when it's displayed. And so when it comes to smoothness, we label things according to an overall stream of frames, which doesn't necessarily match up with what you see in the main thread. So latency, smoothness, and visual completeness have different factors that we would look into. And so for smoothness, we only care about streams of frames and whether they're animated. All right, any questions so far? Awesome. So we could begin to take all of this input and to sort of label frame by frame, what is the value of every single frame, or what is the cost? And so conceptually, every single frame isn't a Boolean value. It is not just either fully presented or fully dropped. Each frame is not either good or bad. It's kind of a fractional value. It depends on how many active animations there were. It depends on the state of what was actually presented. In some sense, it might be worthwhile to consider it a probability, right? We know what happened. What's the probability that that frame was a poor experience for the user? And if you have many frames in a row that dropped animation updates, the sort of probability that this is a poor experience for the user keeps going up. That makes sense. So we track a total over time. So frame by frame, I think we posted this in the web dev smoothness blog post. We describe in detail. So from like least likely to be a problem for smoothness to most likely to be a problem from smoothness, top to bottom. And this is what is happening under the hood. And so you could break down what happens under the hood and sort of map it to a probability or a score. Again, I think Badad's talk tomorrow will go into greater detail here, as well as if you read the blog post that I linked to. I don't really want to spend too much time on the specific details. But even that is not enough on its own, because you have to layer the states of a single frame on top of other factors. So we talked about missing and stale frame content like checkerboarding or late rasterization. Just because we produced the frame doesn't mean the content of the frame included everything that we wanted. There's also the quality of animations. I talked about, or the quantity of animations rather. You know, you could be running animations now, but there could be just a single small one in the corner versus tons of elements animating with lots of variety of animations. You know, that might have an influence as to the importance of a frame. And then we talked about the quality of animation. So like video could be better or worse. Canvas games could be better or worse. So it's not just the rate of frames and whether animations were running. And then long-term aspirations are, it'd be great if we knew the visual size of animation updates, like fraction of viewport, and not just counts of frames and animations. This is pie in the sky, but it would be great also if we knew the semantic value to the user of that animation. Is it just a loading spinner in the corner of some widget that isn't even noticeable, or is it a big transition animation, that sort of thing? All right, so this is where the fun begins, I think. We want to put all of this into a single metric definition. All right, so what is the most natural way to represent the user experience when it comes to smoothness? We think it's sort of the proportion of time that the user waits for important updates. So we have to measure how much time they're waiting. We have to measure what is important. So it starts with, for each animation frame, label smoothness deficits. I kind of showcased that slide earlier. When looking at a series of animation frames, you can convert those labels into sort of a running metric. And then for the whole timeline, you could take all of those slices and turn it into an overall score. So it gets complicated. For more complex pages, there's just a lot going on. So we try to do our best to simplify into a timeline. We don't need to go into details of what these graphs mean. These are different types of, let's call them theories about different things you might be worried about, from main thread only animations to scrolling specific animations to compositor thread animations. If you slice a single page experience over its duration, you'll get different signals of different intensity. All right. This is another recording, much lower intensity of problems. But in this case, the red graph represents some sort of main thread animation. And there was a spike of yellow during loading, which was not really observable because there's loading issues, just lots of things happening. And so the user is not too bothered by smoothness issues during loading in this particular case. And then this red spike happens to happen when there's a lot of scrolling going on. And so the main thread issues are not even observable. So this graph looks intense in terms of the number of smoothness issues found. But if you watch a video of what actually happened, it looks fairly reasonable because scrolling was buttery smooth. The animations weren't observable. This case, which looks way less intense in terms of what's captured, has a lot of like blue, which is very important. It's scrolling issues. It's compositor thread animations. Very, very observable. So in this case, it was very obviously stuttering. And the quality of the animation, or the importance of the animation in this particular example, was very important. So it's not just the intensity of the number of things found. It's kind of, you have to understand the meaning behind it. So we try to merge all this data. So in this case, in the top chart, you have the individual pieces. In the bottom chart, you have how it turns into a metric overall. And you see that the metric that we build is a midpoint between the extremes of the constituent pieces that go into it. All right. And again, this is just some of the experimental metric definitions that we have so far, and they continue to evolve. And so how do we know what the right choices are? How do we know how much weight to put on in all of the individual signals? So one thing we've used as a tool is to do correlation studies against user expectations. So we have lots of good theories as engineers about what might make a good metric. But kind of what we've tried to do is just, let's try them all and see what sticks. And the way we do that is we record a bunch of real sites. We assign expert labels. This site felt smooth to most users. This site felt not smooth to most users. And we see which ones line up best. Which metrics, which experimental metrics did the best job predicting the outcomes as labeled. The world's easiest machine learning problem. And we can get sort of results like this, where we get sort of strategies that tend to do well, strategies that tend to do poorly. We're just sort of scratching the surface of where this is going. All right, we will continue to evolve using those types of approaches and to come up with a better metric definition. But that's kind of the background of how we're thinking about getting what actually matters to users versus the actual signals, the underlying signals that we can detect. So how can you play with the metrics so far? So there are some Chrome UKM values. I threw in a screenshot at the beginning. You can find them by following this link. This is what they're called. There's also performance HUD, which you can enable to sort of see the existing experimental metrics live as you interact with pages. In DevTools, there's some amount of exposure to the underlying signals. And the best way to do it is to use tracing, either with Perfetto or Chrome tracing. So come to the talk tomorrow to really learn more. This is what the HUD looks like if you enable it in flags. You'll see the 3 metrics. So a perfectly good experience will be the one on the left. There's no issues with drop frames. And a fairly bad experience will be the one on the right, where it's just super high. And this kind of showcases the developer confusion, I would say, right now. So this is the state of using the frame rendering stats from DevTools. And frame rendering stats tries to give you a live view of frames, whether they're partial, fully presented, drop, that sort of thing. And so this is a live FPS meter, so to speak. But on my page, I have a FPS meter that is measuring main thread RAF, the number of times we are given a frame rendering opportunity, as well as the impl RAF using an off-screen canvas. So we have 3 different frame rates with 3 different numbers that all disagree with each other because they're measuring a slightly different definition. And this is sort of the reality that developers have to deal with right now. There's just a lot of nuance. And so one of the goals beyond producing a metric is to sort of help unify these. All right, maybe that's enough slides and we can have conversation, but I wanted to also showcase that every single tool does something different. Feel free to go through these things. And I added some fun links in case we want to play with some demos. I will stop talking now. Love questions. No questions so far. How about this? Is anyone implementing sites using animations right now where they have any strategy that they use for measurement that they could share? Has anyone used the DevTools performance recordings and looked at the frame viewer? So let me go back to the slide.
I do that semi-regularly.
Rob, what's your expectation for what those frames should mean, I wonder? How do you use that information?
That's a good question. I expect that they represent like what the user was seeing and when they were seeing it. So I could use that as an indication, swiping through the timeline of like when important updates made it to the user.
Right. So one of the nuances right now, I think, is if we don't consider a frame update to affect smoothness, it won't get labeled red. And so it's a very animation-centric frame viewer right now. But in DevTools performance rendering, you also see, the main event loop and that sort of thing. So is there a mismatch for some, especially as we add, for example, responsiveness metrics, and we want to see from input to output, there might be a mismatch with like the meaning of frames for depending on the developer and what they're looking for. Has anyone read the blog post before this presentation? I told you this will be way more fun if you interrupt. All right. Well, I guess thank you very much, folks, then, in that case. Thanks for coming. Thanks for listening. Nice, John.
Thank you for the talk. It's very interesting.
Thanks.
Yeah, cheers. No worries. Have fun the rest of BlinkOn. And I guess follow along as this evolves.
Thank you, Pat.